Thank you. Good morning, and welcome to Reaching for the Stars, Connecting to the Future with NASA and Hollywood. You know, NAB Show is the place for groundbreaking demonstrations of advanced media technology. And today, we are truly bringing you something that is out of this world. You are here to witness and to be a part of an amazing collection of astronauts, filmmakers, and technology leaders that will take you behind the scenes of the advanced video and cloud workflows that power deep space research, that ignite our imagination about the future in vast areas of science and storytelling, and that create the foundation for the future of space commerce. Today, you will be a part of the first ever live 4K ultra-high definition transmission from space and the International Space Station. The first live discussion with astronauts in space at the NAB show. And an incredible gathering of scientists, astronauts, technologists, and storytellers. Such an effort requires great teamwork. And there was absolutely a fantastic collaboration between our teams here at NAB, Amazon Web Services, AWS Elemental, NASA, and Christie. We must also offer a special thanks to the military and government conference as they enabled Dave McQueenie's participation today. So, as the saying goes, what goes up must come down. What goes up must come down, except when what goes up goes into outer space. And that is what makes the first ever red camera to go to the International Space Station so special. This camera was a vital tool used to further our scientific studies and the interests of NASA's space exploration. It recently returned to Earth, so it did successfully come down. And I'd like to invite Dylan Mathis and Rodney Grubb of NASA and Jared Land, president of RED, to the stage to conduct a brief ceremony with this vital first UHD camera.
In 2015, NASA and RED collaborated to fly a RED Epic Dragon to the International Space Station. This camera has served us very well and has recently returned to Earth after 437 days in space. And it was replaced by another RED Epic Dragon, and it will help us to continue to probe deeper into the mysteries of space. With Rodney Grubbs, I'm Dylan Mathis, as principal investigators for this project, we would like to present to you the first camera back from space.
Thank you.
Thank you.
I always feel like a hobbit standing next to Jared.
Thank you. Thank you.
Thank you again, Dylan, Rodney, and Jared. That is very, very cool stuff. And now it is my pleasure to introduce Carolyn Giardina, technology editor at The Hollywood Reporter, to set the stage for the panel discussion, including our first ever live ultra-high definition conversation with the International Space Station commander, Peggy Whitson, who also just happens to be the U.S. astronaut with the most cumulative time in space. Carolyn, come tell us what to expect.
Good morning. For the next hour, this panel will look at how NASA and Hollywood use advanced technologies and inspire one another. This includes technologies such as 4K and cloud. Today, we will begin by demonstrating for the first time ever a live public 4K broadcast from the International Space Station. And since this is time sensitive due to the position of the ISS, I'm going to quickly hand this over to Sam Blackman, CEO and co-founder of AWS Elemental, for this segment of the session, and then we'll continue with our panelists.
Who's excited? First live 4K transmission from space ever. Let's get right to it. Johnson Space Center, can you do the audio check? Coming. We should hear it in the room very shortly.
Station, this is Houston. Are you ready for the event?
Yes, we're ready for the event.
Please call station for a voice check.
Okay, here we go. Hello, Commander Fischer and Commander Whitson and Colonel Fischer. It is an honor for all of us and those online to join you and all of your colleagues at NASA in the first ever live 4K stream from space. What is the ISS position in orbit right now? "11 seconds.
Well, we're just passing over Baja, California, and we're heading in an arc over North America. By the time we finish talking, we'll be over Central Africa.
Wow. Amazing, amazing. Before we learn more about NASA's use of Live 4K, I'd like to share about Peggy's exciting achievement that was recently made on the ISS and in space. Peggy, you've made 8 spacewalks, and you recently set the record for the most days in space by an American astronaut. Congratulations. What inspired you to become an astronaut?
Actually, when I was growing up, I saw the first men walk on the moon, and I thought, wow, cool job. Of course, it didn't really become a goal of mine. It was just a dream. But when I graduated from high school, the first female astronauts were selected. And that's when it truly became a goal for me. Luckily, I had no idea how hard it would be, and I just worked really, really hard and spent a lot of years getting there, and a lot of hard work. But in the end, I got lucky, and some of that work paid off. So it's been well worth the journey, for sure.
Well, it's an inspiration to thousands of students in the United States and the entire world, so thank you so much. Now, of course, we're calling from the NAB show here in Las Vegas, where next-generation broadcast and production technology comes to life. Are there any films about space that have truly inspired you?
For me, it was definitely The Right Stuff. As a test pilot who, Edwards was my second home. You know the start where he's like flying through the clouds and he's talking about there's a demon that lives on the mater. And then the plane crashes, it explodes, it goes to color. That's just so awesome. And then also Spaceballs, because we're basically flying at ludicrous speed right now.
Yeah, okay. Amazing. All right. We could watch that microphone spin for a long time. So, talking back to technology, can you help us understand the role video plays in your space work?
Well, when we're traveling at 17,500 miles an hour, there's a lot of data going by, even just looking at the Earth below us. And because we're traveling once around the world every 90 minutes, and the Earth is precessing underneath our orbit, we get to see all over the world. And we're in different places each time we pass over a particular area, and so it is amazing amount of data that allows us to capture some of that in high resolution. But actually inside the space station, we're also capturing a lot of data, high data resolution for the scientific experiments. Inside the racks that we have around us, we have many different types of experiments, either cell cultures, microbiological cultures, protein crystallization. We're doing combustion experiments, and lots of studies looking at different physical properties. So it's very exciting, and being able to capture a lot of data is very important from us scientifically.
Cool. What do live 4K and Ultra HD help you do on board the ISS in terms of scientific research that you couldn't do before?
Well, I think Peggy mentioned a lot of the reasons. You know, with these new cameras and new technologies, we're able to get higher resolution, higher frame rates, to capture different science for some of our experiments, ultra slow motion for some of the effects that are very short-lived, yet very important. So there's a lot of science both on the station, looking at the Earth, and I think even more importantly is the inspirational aspect, because, you know, 4K and ultra high def actually make you feel like you're there. I mean, if you look really close, you can probably see into my pores right now. Granted, nobody wants to see there, but everybody wants to see the Earth from this vantage point. And by looking down at the Earth with this amazing new technology, we're able to inspire an entire new generation of explorers. So I think probably the biggest impact that these technologies will have is bringing everyone else on the planet to see these amazing sights that we get to see every day and inspire them to push beyond just living on Earth.
Absolutely, yes. All right, so the moment I've been waiting for. Can you show us some experiments in space in live 4K?
Actually, we'd love to do that. And so a lot of these are kind of things that we do maybe to have a little bit of fun, that just because you can do them in zero gravity. So we're going to play a little ping pong, but it's kind of space ping pong because we're going to use a ball of water as our ball. So Jack's going to build a ball of water here with the pushing water out of the straw of the drink bag. He's got a little ball of water, and we're going to play ping pong. And now we'd like to show you another demonstration. The next one I think we'll go after will be what we call, actually it's going to be a ball of water, but it's got a little additive put in it. We're going to add a little Alka-Seltzer to this ball of water and let you see it. And we're going to move up close, so we'll get our focus up here a little closer so you can see it in more detail.
Amazing. Oh.
And a little food coloring added to that. And of course, all of these things are happening because of the surface tension plays such a big role, and it's not impacted in zero gravity by the forces it is on Earth. So that's a really fun way to demonstrate that. Another really interesting thing is something called thin films, and you can do them also here in zero gravity. We're going to get set up for that one. Okay, so I've got a little bit of water in this plastic bag, and I'm pulling out, whoops, it broke. Stand by, we'll try it again. I may have to let that microphone go.
That is a benefit to PRs in space. You really don't have to hold your mic.
Okay, I gotta get the water shoved over here to the side. So I have a very thin film of water here. Okay, and Jack's got a little bit of food coloring. We're going to add to it.
One more, right?
Wow.
Oh, that's great. Come back.
It's amazing. Peggy, Jack, I don't know if you can hear the oohs and ahs in the audience here, but it's tremendous. It's just so, it's mind-blowing to be watching this in real time. Wow. How do you imagine the future of NASA in terms of where advanced imaging technologies will take you next? Say maybe Mars?
Actually, I think advanced technologies are going to be required to go to Mars, and especially advanced imaging. Obviously, it's important to us to better understand where we're headed, and it minimizes the risks if we better understand that in advance. And so all the studies, all the imaging studies from different rovers and missions that we send to Mars before we actually arrive are going to be critical to a lot of the decision process that will occur. You control it. Get it in focus.
Just so fascinating. Okay. Well, Commander Whitson, Colonel Fischer, this has been one of the most remarkable exchanges I have ever had. Your insights are fascinating and inspiring. Thank you so much for taking the time to share them with us and the entire NAB audience and thousands online. Congratulations on all your accomplishments, and we look forward to a lot of live 4K UHD from the space station for years to come. Thank you. Wow. Think about the
Station,
technology.
this is Houston ACR. That concludes the event. Thank you.
Thank you so much. One more round of applause.
Thank you to all of the participants at the Las Vegas Convention Center. Stations, please stand by. We are now resuming operational audio communication.
So the number of technologies that goes into making an exchange like that possible, seeing how the teams from NASA and AWS Elemental have worked together over the past month, the amount of technology from those networks coming down from the space station, from 4K encoders, from distribution over CDNs to thin film displays all around the world, it all builds on itself to make something like this possible. And I know I'm deeply honored to be here today and be a part of it. And I want to thank everyone here so much for taking the time to come and see history in the making here at NAB. Thank you. All right, next up to explain how this magic actually works, can Carolyn come back up to the stage, please, along with the panel that's going to be explaining all the amazing technology to us. Thank you again.
So let's just take another moment to congratulate NASA Services, AWS Elemental, and NAB on that amazing first look into the future. We'll talk more about that in a few minutes, but first let me introduce our panelists. Seated next to me is Dr. Dave McQueenie, who's Vice President of Corporate Technology at IBM. Next is filmmaker Bernie McDade, former head of content at Discovery Science Channel, and since then she founded BUA Entertainment, which is a creative consultancy specializing in virtual reality. We are thrilled to welcome U.S. NASA astronaut Dr. Tracy Caldwell Dyson. Dr. Dyson flew aboard the Space Shuttle Endeavour on a long-haul ISS mission and is a veteran of 3 spacewalks. She has and she's logged more than 188 days in space. Oops. Also with us this morning is Khwaja Shams, Vice President of Engineering at AWS Elemental, and also a veteran of NASA's Jet Propulsion Laboratory. And last but not least, we have Rodney Grubbs, who is the NASA Imaging Experts Program Manager and chairs the NASA Digital Television Working Group. So welcome, everyone. So as each of you watched that inspiring 4K live stream just moments ago, what was going through your minds? What were you thinking about?
You know, the thing that occurred to me was when the first moon landing, 600 million people watched that landing on a grainy black and white television. I'll start again. When 600 million people watched the first moon landing on a grainy black and white television, and when I see this incredible technology, just imagine what your children and your children's children are how they're going to experience further space exploration as we move forward, and how that's going to inspire them. And I think that's pretty incredible. You know, because you heard Peggy say herself, it was seeing that moon landing that made her determined to become an astronaut at a time when NASA didn't consider female astronauts. And I think that's an incredible thing.
Yeah, and I would say that when Jack made his comment about these higher resolutions enabling everyone on Earth potentially to be there on the ISS with them, I mean, they're up there because of the resources of, you know, not just one country, but many countries, and the ability for technology to let any of us be immersed there and to be inspired by it and to learn from it, I think is very impressive. And that was what Jack's comment was on the video, and I thought that was perfect.
Dr. Dyson.
Well, I think it just means astronauts have to step up their game because you can see everything in 4K. So we've really got to be, I think it was important that Peggy and Jack actually rehearse a little bit before performing those demonstrations. But in the same vein, when we're making a video for scientists on the ground to analyze their data, we really got to, we get a lot of data, but we also need to be, as astronauts, technically savvy and also careful with how we set these things up, just to make sure we get, the data that we collect is the data that they need, because you do see everything.
And are you also a ping pong pro?
Yes, yeah, you definitely got to practice your serve with that.
He cheated.
That's right.
Just a little.
Question, Rodney, I know this was enormous effort to put together. Can you maybe just tell us a little bit about behind the scenes to get here, and then what you thought when you watched it?
Well, my thought was, wow, am I glad all this is working. So we've already seen in the last 5 minutes doing live television isn't easy. Try doing it with brand new equipment and so forth. So we've got a great team, and seeing everything come together. 3 months ago, we drew all this stuff on a whiteboard in Houston, Texas, and I took a picture of it and sent it to some very smart people, and here we are.
Wow. So, what was the most challenging aspect of the effort?
Well, as a technologist, I was inspired by the fact that we now have, this technical feat of 4K video coming from space. But as I watched the video, I learned that I found my own passion for space reinvigorated. And I realized that the video is just a vehicle. It's the content that I'm most excited about. When you see space ping pong happen, and you see how it inspires the younger generation to just wonder a little bit more about what really goes on in space and aspire to get to space faster. I think that's what I'm most excited about, and that's what goes on to my mind when I watch a video like that.
Yes, great. So now IBM has actually been involved with NASA since the beginning, and as many of you probably saw in the film Hidden Figures, IBM's computing power and the innovators behind it have played a big part. Dave, what inspires continuing development of cutting-edge computing systems?
Well, in the movie Hidden Figures, the techies in the audience will probably remember a discussion about the orbital physics of an elliptical orbit of a spacecraft orbiting, transitioning to a parabolic orbit, or kind of a trajectory through the atmosphere. And at the time, they didn't have a closed-form mathematical solution to that, and so they had to model that numerically. And at the time, a computer was a job title, not a machine, right? It was the human folks in that movie that we were so inspired by, and it was that connection of those humans to the mission. And you remember the astronauts in the film, they placed their trust in those computers, those human computers. They knew if they say it's right, then we're willing to bet our life on it. So that connection between humans and technology goes back that far. And I've talked to some of the IBMers who worked on the Mercury and Apollo program. Homer R. is someone I met recently at an event we had marking an anniversary. And he told me at the time, as much as we needed rockets and ballistic trajectory, mathematics and everything else, we needed compute power. Those programs didn't work without compute power. And so the IBM folks that worked on those missions knew that their innovations, beyond anything they had done before, were literally going to be necessary to bring a spacecraft back from orbit, or to get a spacecraft to the moon. And so there was, again, that inspiration of the technical challenge and the power of the human and the computer. We saw it again when we played chess against Garry Kasparov with the Deep Blue chess machine. And at the time, we knew that computers were capable of much more than just adding up ledgers and doing payroll. We knew that computing could impact the front office of business, and we looked for a way to demonstrate that to everyone. And so we played chess against Garry Kasparov. And again, it inspired people at a level that totally surprised us. We did it again with the Watson technology. We put it on TV playing Jeopardy, where we said, computing is now not just at a point where it can do front office business stuff. Computing is at a point where it can start to have a small understanding of human language. Most of our clients, 80% of their data is unstructured, and they get not enough use from it. So that was a way of showing people, here's a way that we can teach computers the knowledge of a human expert at at a modest level and actually take this vast array of data that's underutilized and start not only getting insights, but to interact between the human and the computer in the human's language rather than the computer's language. So we call that cognitive computing, and it's that inspiration of that Jeopardy match has led to dozens and dozens of very interesting real-world applications of this technology. It's opened up all kinds of vistas for future innovation. And the last comment I would make is, now that we've learned to use all this formerly dark data, now that we've learned to impart some human intelligence to a machine to augment a human's expertise and to converse with the human at a natural human level with these cognitive technologies, we now find ourselves wanting even more compute power. And so one of the other things that we've done recently is we've taken one of the world's first quantum computers, or just a 5-qubit quantum computer, and literally put it up on the web so that anyone on the planet can submit programs to run on that. And we've had hundreds of thousands of programs submitted from people all over the world, some original scientific papers written as a result of these early inquiries. And it represents the next enormous shift in compute power, because instead of building computers out of atoms, we'll actually use the properties of those atoms to do computation. So kind of turning the tables on nature. And the inspiration that happens when the humans and the technology interact that way is, I think, what propels everything forward.
Fascinating. We're going to move to Kwaja. So as we go in that direction, substantial engineering challenges are involved in bringing 4K to the screen, space to our screens. Can you talk a little bit about those challenges?
Sure. We got to participate in some of the challenges that people at NASA are dealing with on a daily basis. So we got a little glimpse into that as we worked through this. When you're sending equipment into space, it has to conform to, the equipment has to be durable, because the deeper in space you go, the harder it becomes to replenish hardware. When you're sending equipment into space, you have a tight power and heat dissipation budget, and you want to make sure that you're remaining under tight constraints because you don't have an infinite amount of resources. And it has to be durable so that it can work through harsh radiations and other exposed elements that you have in space. So that's just one part of getting something that is up and ready to be transported into space and can continue working. After that, the challenges are getting the data back from the space station down to Earth. And fortunately, NASA has spent decades perfecting that technology, making sure that we have the maximum amount of bandwidth that we can possibly get, minimum amount of latency, highest possible resilience, because that's our lifeline to the station, and we want to make sure that we can get that data. Since that pipeline has already been built, we were able to just stand on their shoulders of NASA and get the 4K video stream down to Earth. So that's the first mile problem that NASA made really, really easy, or at least you guys made it look really, really easy for us. Then there's the middle mile and then the last mile. The middle mile is making sure that for a live event, you want to make sure that you have highly resilient infrastructure, because there's a lot of people tuned in watching at the same time, and you don't want to do anything to compromise their experience. You want to make sure that you have the highest possible quality, video quality in the stream that's being processed. You want to make sure there's no disruptions. You want to make sure that despite the fact that there are viewers at home that have varying internet bandwidth, they can still get the maximum possible number of pixels on their screen, so they can see and experience this content in the highest possible resolution. So to deal with some of those challenges, we provisioned each of these things inside an elastic cloud inside of AWS. We, to make sure that they're resilient, we try to keep these things running in multiple data centers. We place the content across our edge points of presence in CloudFront to make sure that the data is becoming closer and closer to the end user, so that we can maximize the bandwidth and minimize the latency and give them the ultimate possible immersive experience to view the space station.
Fantastic. Okay. Now, Bernie, you produce science documentaries as well as TV and features. What impact do new technologies like 4K and virtual reality have on the sorts of stories that you can tell now?
Well, I would say the advent of 4K and virtual reality is probably the most exciting time to be in storytelling since we transitioned from radio to television. Not that I remember that personally, I hasten to add. Right now we buy a ticket to go to the cinema to watch a story unfold in front of us, and this technology is going to allow us very shortly to go to a cinema and be in that story that's unfolding in front of us. And I think the gifts of 4K and VR are twofold. Firstly, it democratizes experience, and it also promotes empathy. And what I mean by democratizing experience is that regardless of your age, size, physical ability, we can take you on a journey to discover this world and beyond to other worlds. And, you know, so pretty soon, I won't have to go through the rigorous training and be as smart as Tracy is to be an astronaut. I can just pop my goggles on, and how marvelous is that? So I think that's a real advantage. And of course, with empathy, I think particularly in the current political climate, it would certainly help to allow people to step into someone else's skin for a while and see what their experience is on a daily basis. You know, so as we forge forward into the future and hopefully to colonize other planets, perhaps if we come together as a population on this planet first, then VR and 4K can play a role in that.
Okay. Dr. Dyson, what role does Live 4K Cloud play in your work, gathering diagnostics and experiments?
I think on orbit, it's becoming more and more useful as it is important, because as the station grows in terms of the investigations, the scientific investigations, we astronauts have fewer opportunities to really dive into the actual details of the science that we're setting up and helping to produce data. So having 4K and the cloud, the ability to bring this work down in high definition allows the investigator to really do their job and to be able to see the detail that we perhaps would miss in trying to relay this information to them otherwise. And so I think the greater our capability in bringing down definition in these scientific experiments in particular, the greater ability that the researchers have on the ground to use the data that we're collecting for them.
Are there any specific examples that you could of something that you're working on right now in using this?
Well, so when I was up on orbit, we had an experiment called CFE, and it was critical fluid dynamics, and using shapes of vessels to propel liquids from point A to point B. And it has its application in fuel tank design for spacecraft, where you could propel fluid without any kind of moving parts, which is very important when you're trying to reduce mass on a spacecraft. And one of the most important components of setting up this experiment is the video camera. And if you were to walk into mission control during one of these experiments, you would see very huge apparatus, which was actually really this big, but it's blown up huge on the screen, and a timer. And then you would hear the principal investigator in the background with all his oohs and ahs and excitement over what he's seeing through the video. And so I can only imagine 4K, what that would be telling, and that's even without all of the timing data and the dimensional data, but just what he's watching through the video and is being transmitted to him in a level of information as well as inspiration. That's just one example.
Fantastic. Now, Rodney, NASA has achieved this technology first today with the live stream in 4K from space. What lies ahead? Can you talk a little bit about the role that live 4K in the cloud will play as humans move farther from Earth and toward Mars?
Right, so there's a lot of components to imaging from space, right? So part of it is the compression. So we used H.265 compression today for the first time. And bandwidth is very precious, even though we've increased the amount of bandwidth we get from the station. As we start moving further out and start putting human presence around the moon and then start talking to go to Mars, that amount of bandwidth that we can get back from the spacecraft gets smaller and smaller. So if, as a technologist and somebody interested in having compelling content for filmmakers, we need to, if we're going to do 4K when we go back to the moon, or the moon area, the cislunar space, I've got to fit that into a smaller pipe. So the compression was really important. Better pixels, more pixels, and being able to down select a frame or a segment inside a larger space in the image is also very, very valuable. So as we go from 4K to 8K, maybe someday, sooner maybe than people might think, what that actually lets us do is shoot a very wide field of view and still have extremely high resolution in a smaller part of it. So there are a lot of aspects of doing demonstrations like this that are going to get us ready for the kinds of things that we're going to be doing, hopefully, in the not-so-distant future.
So from here, what are some of the next demonstrations and tests and things that you'll be working on?
Well, one of the things that we've talked a little bit about VR, one of the things that we're interested in VR technology for is right now on the space station, on the outside of the space station, we have pan-tilt cameras. These units were built over 20 years ago, and they're very, very heavy and very clunky. And everything you take in space is precious. Every pound that you take is precious. And so simplification and making things smaller would really pay off, particularly if you're in cislunar space and you've got proximity operations of a spacecraft approaching, for example. So if I can get the functionality of pan, tilt, and zoom by oversampling and having a VR camera with no moving parts, I've solved a whole bunch of problems for us. We don't have to launch this big complex device that's heavy that points the camera around, and what if there's something going on in front and something going on in the back? With something like that, we would be able to get a lot of detail and have operators on the ground looking at everything around them with no moving parts.
So can you elaborate a little bit on what's up there right now and what are you using?
Well, the most advanced motion imagery camera is the one we just saw used right there, the Red Epic Dragon.
Right.
Day-to-day cameras are routine HD cameras. We have a Canon 305. These kinds of demonstrations usually result in more and more of the next thing, right? And so the natural progression would be more and more UHD 4K and use of H.265 so we can get even more streams down to the ground. We have a few things that we're trying to do in the next few years. You're going to start seeing the space station used as a laboratory to get us ready for these technologies as we start getting ready to move to cislunar space.
And if I could just jump in there. So I don't know if everybody's aware, but NASA is a huge partner in the filmmaking business, and they're huge collaborators. And oftentimes they will supply exceptionally high-level, high-quality footage for films. I made a series called Secret Space Escapes, and frankly, the NASA footage was HD, and it was the highest quality we had from the International Space Station, which is pretty incredible. So when Rodney told me that they were looking into putting virtual reality cameras on the ISS, like that's an enormous resource for film producers too, and of course in turn that's how you inspire people to move forward, you know, whether it's to become scientists or just to be, you know, donate to the scientific cause. So it's all, like, you know, hugely positive. I love the author of The Little Prince said, if you want to be an explorer on the great sea, don't divide people up to collect wood and buy a ship. Inspire them to yearn for the open ocean. And I think that's why scientists and filmmakers are such a kind of symbiotic relationship, and we kind of feed each other. What was the name of the circle?
The virtuous circle that we talked about? The virtuous circle?
The virtuous circle. You mentioned that yesterday, and I said, well, no one's invited me to that.
You know, I want to pick up on something you said about the latency problem and the premium on bandwidth. We saw a really interesting example with the 11-second delay up and down to the ISS, and if I look at, you know, one of the computing revolutions happening today that's often called the Internet of Things, so taking these sensors that are deployed in a lot of the physical world and bringing back a digital image of the physical world that we can then manipulate, you run into an interesting conundrum because computing power growing like this, data volumes growing like this, all almost by definition coming from the edge, but then communications bandwidth growing more slowly, even terrestrially. So the innovations that NASA is going to be forced to make to support spaceflight of more autonomous computing at the far end, skinnier communication pipes, there will be another revolution in the compute industry that is likely to be led by the folks from NASA, just as, you know, in many ways, the original computing revolution was led by programs like Mercury and Apollo.
The big difference, though, to our advantage is in the Apollo era, NASA had to invent it. Now we can leverage technologists and things like what we've seen and talked about here and maybe give you a hint or two of that's really cool, but could you do a little bit of this and a little bit of that, and you know, seeing all this commercial off-the-shelf technology pull off what we just did, we didn't have to invent anything. We were just able to leverage what you folks build and design and take advantage of it.
But your mission inspires, and just the way Bernie was talking about, your mission compels people to gather the wood for the ships in a way like no other institution I've ever seen.
I want to also reemphasize one of the points you made earlier around the higher resolution and the role that it plays. As you go deeper and deeper into space, the longevity of your hardware becomes more and more crucial, right? To get to Mars, you know, it's a 9 months to 24-month journey, depending on where you are on the planetary rotations. It is really hard to think about hardware that you have to replace. Even lubricating these moving parts is so much more difficult. And if you can take away that need to have moving parts, if you can have that perspective, one, you have increased the longevity. Two, what you have done is you may not know what you're actually looking for until later. And having that wider field of view allows you to go back and take a look at some side effects or something else that might have been interesting that you didn't think it was interesting at the time that you captured it. But what video does is it allows you to capture these moments into perpetuity so that when you become interested, you can go back, look at the data again, to your point, and learn from it again. So,
you know, I feel inspired to mention this, though I don't know the conclusion, but on spacewalks, you know, we have 2 cameras on our helmet, and then whatever external cameras that we have that can look at the position where the astronauts are during the spacewalk. And that gives us in mission control an idea of what's going on during a spacewalk. And it wasn't until recently that I believe it was Terry Virts that took a GoPro camera out on a recent spacewalk, and how that opened up everyone's eyes to the reality of what actually goes on. I mean, we got a step closer to what we actually see through our visor when we're out in the vacuum of space. And I think with 4K and the considerations that we have to make in order to put things in space that bring back such incredible images, miniaturizing it and making it durable for the extremes of outer space, the temperature extremes, the atomic oxygen, the vacuum of space, and then just the rigors of being in a spacesuit and working around hardware, to be able to capture the magnificence of being literally in outer space. I just can't wait to see when we're able to pull all of that together to bring it from the inside of the space station to the outside.
What are some of the ways that viewers can currently watch what's happening on NASA TV and the like?
Well, I know that we run live streaming video from what we say DPC to DPC, daily planning conference to daily planning conference. So the beginning of an astronaut's day to the end of it, there's live streaming video from one of the cameras in the module, depending on what's going on that day.
Right, there's an external HD camera system called HDEV. My colleague Carlos, sitting in the audience, is the principal investigator for that. Those are 4 cameras that are sitting on the outside of the station, always looking down. And you can look that up, and when it has a signal, you can see that 24/7, 365. When it doesn't have a signal, of course, it'll just say, we'll be right back, basically, once we get a signal. And we're starting to put HDTV cameras out on the space station. You know, the International Space Station was designed and built before anybody even dreamed of HDTV. And so we've had to sort of retrofit some of these systems and the communications that are on board the station to make all of these things work. It wasn't so long ago that doing internet protocol anything on the station was very, very difficult and impossible. And so now that we basically have an internet in space, and we even have Wi-Fi on the outside of the space station now, for people like me, I get pretty excited about that, because it means maybe on a future spacewalk, somebody can leave a camera sitting out there in a spot we haven't seen before, and we can occasionally see that point of view as well. But the NASA television is up on satellite, and it's streamed all the time. There's lots of different ways of seeing what's going on. NASA's charter says, in its charter, everything that we do is owned by the American taxpayer, and we're to make it available to them in the most practical way we possibly can, and a lot of us work very hard to do just that.
Yeah, and also social media has propelled NASA into people's lives in a way we've never seen before this century. So it's almost, they're really leveraging their advantage of this incredible imagery that they have, and then of course through the advantage of sharing and all that. So it's almost that they're moving from a brand to a lifestyle. So if you are interested in NASA, I would encourage you to sign up for their Twitter account and Instagram account, because it's pretty cool.
Thanks for the plug.
Thank you.
Start winding down, but one thing I did want to make sure we talked about, since is NASA Hollywood, is Dr. Dyson, you were consultant on Ridley Scott's film The Martian. Can you tell us a little bit about that experience?
Yes, I've had the honor and privilege of working with Jessica Chastain on her role as Commander Melissa Lewis. It was all her doing. She asked if she could go to space camp, and Ridley rigged it up so that she could visit both JPL and Johnson Space Center, and she wanted to meet with a female commander type, and I was the lucky one that got to spend a day with her in our training facility. And to sum it up, she's a researcher, Jessica is, and she takes any role that she is given very seriously. By nature, she told me that she's more of an emotional person, and what she really wanted to do is dramatize her character, but what she walked away with was this sense of the intensity of the work that we do as astronauts. So I felt in some ways bad that she had to suppress her inner being, but I was admiring her all the more because of the character that she portrayed. I felt not only honored the work that we do, but it was also very important to her to understand the technical aspect of it as well as the human side of it. And that's what I think that the media and Hollywood in particular does in great favor to NASA, because NASA's really busy with the geeky side of things, and we're not always at the top of our priority list how to express it to the rest of the world, something that they own and it belongs to them. But through our actors and actresses, they do a very good job of capturing the human side of it. And in fact, to Jessica, she asked me as many questions about the technical side of it. What does it take to be a commander? What's your role of a commander on the space station, both every day and when the bad things happen? She got really into the details, but then she noticed I was wearing a wedding ring. And she said, did you wear that during your mission? And I said, every day. And so she said, that's great. I want to incorporate that. And it was very important to her to capture the human side of it. And she did that in more ways than just what you saw on the screen, but in pulling all of her castmates together during the filming, she really brought to life crew camaraderie, and what really binds the mission together are the people, both up in space and on the ground and in between. So I think a big tribute to Hollywood and Jessica in particular.
Well, we're out of time, but I just like if one of you would make a closing comment on what space and storytelling can now bring to STEM education.
No, please. Spoken.
What was the last part of the question?
What it can bring to STEM education.
To STEM. STEM. I'm sorry.
STEM.
Yes.
STEM.
So, you know, if you go to the public and you ask them a question about space or NASA in general, almost always the answer that you will get from them is actually a description of imagery. And so if you think back to what it meant when we got a picture back of our pale little blue dot as the Apollo 8 spacecraft went around the moon, and they had that Earthrise, and they said, oh my God, look at that, just grabbed the picture and took those photographs. How many people were inspired by just an image like that? I want to be a scientist. I want to be an engineer. Look how fragile that blue dot is just from that photograph or those images. And so I think we forget sometimes when we're being geeky just how something simple like a demonstration like what we just saw, there's no telling how many people may have seen that, young people, and said, you know, instead of doing what I thought I was going to do, maybe I ought to pay more attention in math class or learn a little more about physics, because that was cool. Right?
Yes, absolutely. Okay. So again, we are out of time. Please join me in thanking our speakers and also in congratulating NASA, Amazon Web Services, and NAB on their demonstration.